அனைவருக்கும் வணக்கம். We are discussing atomic structure in chemistry subject. So நம்ம last classல atomic structure part 1 பார்த்தோம். அதனுடைய continuation atomic structure 2 நம்ம இதில் பார்க்கலாம். So in this class we are going to see some important basic concepts and followed by the questions based on the concepts. Come on, let's go to the class. So here the first one is, so while studying atomic structure you should know some important basic things like atomic number, mass number, isotopes, isotones, isobars, etc. So the first one is atomic number. The symbol is Z. The atomic number concept was put forth by Moseley. So what is atomic number? So the number of protons or electrons present in an atom is known as atomic number. So here the number of protons and electrons should be same in an atom, then only it will be neutral. If any one of these species is more than the other, then the atom become a charged particle, that is ion. If positive charge, that means the number of protons are more than the number of electrons, then that is known as positive ion. If the number of electrons are more than number of protons, it should be known as negative charged ion. Okay, the second one is mass number. The symbol is A. So here the sum of protons and neutrons. The protons and neutrons combinedly known as the number of protons and the number of neutrons are commonly known as mass number. The number of protons and the number of neutrons, they are commonly known as nucleons. So they are present in nucleus. The number of neutrons in an atom will be calculated. N is equal to A minus Z. A is the mass number and Z is atomic number. Usually it is a symbol to represent an element. Okay, so by this representation we can express the atomic number, mass number and the symbol. By combining these two we can write like this. Okay, see for example, if you take hydrogen atom, so this is a symbol of hydrogen atom and this is atomic number of the hydrogen atom and this is a mass number of the hydrogen atom. Okay, if the mass number of the hydrogen atom is 2, that is known as deuterium. Okay, so here 1 is the atomic number, that means Z, the atomic number should be written at the bottom of the symbol and the mass number should be written at the top of the symbol. Okay, now some more concepts like isotopes, isobars, isotones. So these are all based on the number of protons and number of neutrons and number of electrons. Okay, first of all, what are isotopes? Iso means same. So here any of the quantity will be same. If the atomic number is same, then that is known as isotope. Atoms of the same element having same number of atomic number, same atomic number are known as isotopes. Here the mass number will vary. See for example, you take hydrogen, there are 3 isotopes for hydrogen, H11, H12 and H13. So here the H11 is known as protium and H12 is known as deuterium and H13 is known as tritium. So we have discussed already, tritium is the radioactive element, lightest radioactive element, tritium, it is H13. So here H12 is known as deuterium, that is heavy hydrogen, from which you can get heavy water, D2O. So it is represented by D and this is by T, T13 like this. The second one is isobars, atoms of different elements with different atomic number, but here the mass number is the same. மாஸ் நம்பர் நிறைய ஒன்றாகவும் அணியன் வேறையாக இருந்துச்சுன்னா அது நம்ம ஐசோபார் அப்படின்னு சொல்கிறோம். ஓகேங்களா, எங்கள் எடுத்துக்காட்டுக்கு ஆர்கான் 1840 எடுத்துங்க, பொட்டாசியம் 1940 எடுத்துங்க. ஸோ ஹியர் the atomic number of argon is 18 and that of potassium is 19. So here the atomic number is different, but if you see the mass number, both are 40. So here in this case the mass number is same but the atomic numbers are different. So these are the examples for isobars. And isotones, so here in isotones the number of neutrons of 2 atoms will be the same. Number of neutrons ஒன்றா இருந்துச்சுன்னா அது வந்து நம்ம isotone அப்படின்னு சொல்கிறோம். Okay, see for example, if you take carbon 614 and nitrogen 715, okay, so here So here the number of protons change ஆயிருக்கு, mass number different இருக்கு, isn't it? But the number of neutrons should be the same. How will you calculate the number of neutrons? N is equal to A minus Z. So here it is A and this is Z. 14 minus 6 is 8. So here 15 minus 7 is also 8. So here in both the cases the number of neutrons are 8. So they are having same number of neutron. So they are the examples for isotones. There are some more terms. The one is isostar. Isostars are the molecules having same number of atoms or same number of electrons. சரிங்களா, அணுக்களின் எண்ணிக்கையோ அல்லது எலக்ட்ரான்களின் எண்ணிக்கையோ ஒரே மாதிரி இருந்ததுன்னா நம்ம ஐசோஸ்டார்னு சொல்றோம். எக்ஸாம்பிள் N2 plus N2 and CO எடுத்துங்க. In nitrogen molecule there are 2 atoms. In carbon monoxide also there are 2 atoms. So in both the cases there are 2 atoms. If you see in terms of electrons, so here the electrons for nitrogen is 7 plus 7, 14. Okay, for carbon monoxide, for carbon it is 6 and for hydrogen it is 8. So that 8 plus 6 it is 14. So the number of electrons are also same. So in CO2 and N2O, carbon dioxide and nitrous oxide, total number of atoms 3. Here also it is 3. So these are the examples for isotars. Isostars. Isoelectronic species. Okay, so here the number of electrons in these cases will be equal, will be same. If you take carbon monoxide, cyanide and nitrogen, in all these 3 species, totally 14 electrons will be there. So they are the examples for isoelectronic species. Isoelectronic species la electronகளின் எண்ணிக்கை சமமாக இருக்கும். சரிங்களா, இப்போ இதை பேஸ் பண்ணி நம்ம என்ன பண்ணலாம், ஒரு क्वेश्चंस பார்க்கலாம். இந்த கான்செப்ட் பேஸ் பண்ணி இந்த ஃபர்ஸ்ட் क्वेश्चन பாருங்க, வாட் ஆர் ஐசோடோன்ஸ்? ஐசோடோன்கள் என்பவை யாவை? ஸோ நம்ம ஏற்கனவே சொல்லியிருக்கோம், ஐசோடோனில் என்ன ஒன்றா இருக்கும், உங்களுக்கு நம்பர் ஆஃப் நியூட்ரான்ஸ் சேமாக இருக்கும். இஃப் த நம்பர் ஆஃப் நியூட்ரான்ஸ் ஆர் சேம் தென் தே ஆர் நோன் அஸ் ஐசோடோன்ஸ். எங்கே இருக்கு பாருங்க ஆப்ஷன், ஆட்டம்ஸ் ஹேவ் சேம் நம்பர் பட் ப்ரோட்டான்ஸ் டிஃப்ரெண்ட் நம்பர் ஆஃப் நியூட்ரான்ஸ் கொடுத்துருக்காங்க. ஓகே, ஸோ ஹியர் டிஃப்ரெண்ட் நம்பர் ஆஃப் நியூட்ரான்ஸ் கொடுத்துருக்காங்க. ஸோ இட் இஸ் நாட் த ஆன்சர். ஹியர் இட் இஸ் given as same number of neutrons. Yes, it is. இங்க பாருங்க, சேம் நம்பர் ஆஃப் புரோட்டான்ஸ் அண்ட் நியூட்ரான்ஸ் ரெண்டுமே ஒன்றா இருக்காது நம்ம பார்த்தோம். சரிங்களா, ஸோ புரோட்டான் மாஸ் நம்பர் வேரி ஆகுது அப்படின்னா கண்டிப்பாக புரோட்டான்ஸ் நியூட்ரான்ஸினுடைய நம்பர் ஒன்றா இருக்காது. ஓகேங்களா, ஸோ ஆட்டம்ஸ் ஆஃப் த சேம் எலமெண்ட் வித் டிஃப்ரெண்ட் மாஸ். ஸோ இங்கே மாஸ் பற்றி நம்ம சொல்லவே இல்லை. ஸோ ஹேர் த செகண்ட் ஆப்ஷன் சேம் நம்பர் ஆஃப் நியூட்ரான்ஸ் இருக்குது. ஸோ த ஆன்சர் இஸ் பி. ஒத்த நியூட்ரான் எண்ணிக்கையும் மாறுபட்ட புரோட்டான் எண்ணிக்கையும் உடைய அணுக்களுக்கு ஐசோடோன்கள் என்று பெயர். ஓகே, if the mass number of an element is 16 and the atomic number is 8, then the number of neutrons. ஓகே, நம்ம ஏற்கனவே சொல்லியிருக்கோம் n வேல்யூ கண்டுபிடிக்கிறதுக்கு n is equal to a minus z formula. Okay, a minus z number of electrons. So here in the case the mass number is 16. Okay, the atomic number is 8. So 16 minus 8 is 8. So there should be 8 neutrons. So number of neutrons are 8. So here the option is B. So in the second question, calculate the number of protons, neutrons and electrons in bromine 3580. So bromine 80 isotopல இருக்கக்கூடிய புரோட்டான்கள், எலக்ட்ரான்கள், நியூட்ரான்கள் எண்ணிக்கையை கணக்குன்னு கேட்குறேன். சரிங்களா, நம்ம ஏற்கனவே பார்த்துருக்கோம், if you take an atom, the atomic number is equal to the number of proton, that should be equal to the number of electron. So இது மூணு ஒன்றாமே இருக்குன்னு பார்த்துருக்கோம். So here the atomic number is 35. Okay, so there should be 35 protons and 35 electrons. சரிங்களா, number of neutrons எப்படி கண்டுபிடிப்பீங்க, a minus z. So here a is 80 and z is 35. So 80 minus 35 is 45. Okay, so the number of neutrons 45. So these are the answers. எங்க இருக்கு பாருங்க, எந்த சாய்ஸ்ல இருக்கு பாருங்க. ஸோ இங்கே வந்து புரோட்டான் 80 கொடுத்துருக்காங்க. ஸோ இட் இஸ் ராங். ஸோ இங்கே புரோட்டான் 35 பட் எலக்ட்ரான்ஸ் ஆர் 55. இட் இஸ் ஆல்சோ ராங். ஸோ இங்கே பாருங்கள், புரோட்டான்ஸ் எலக்ட்ரான்ஸ் 35 இருக்குது பட் த நம்பர் ஆஃப் நியூட்ரான்ஸ் இட் should be 45. ஸோ ஹியர் 80 is there. ஸோ இட் இஸ் ராங் ஒன். ஸோ ஹியர் 35, 45. Okay, so the answer is option D. Okay. Yes, the next. So another important thing. So there are several electrons. There will be several electrons in an atom. How will you differentiate one electron from another electron? So as to make it easy, so the quantum numbers are being introduced. So there are 4 quantum numbers: principal, azimuthal, magnetic and spin quantum numbers. சரிங்களா, முதன்மை குவாண்டம் எண், கோணவந்த குவாண்டம் எண், காந்த குவாண்டம் எண், தற்சுழற்சி குவாண்டம் எண் என 4 வகைப்படும். ஓகேங்களா, இதில் இந்த சிம்பிள்ஸ் எடுத்துட்டோம்னா, பிரின்சிபல் முதன்மை குவாண்டம் எண்ணுடைய சிம்பிள் வந்து n. It denotes the orbit in which the electron is revolving around, so that it gives the size of the atom. If the n value is 1, only one orbit will be there. If n value is 2, there are 2 orbits, so that the size of the atom will increase. Okay, so this quantum number is introduced by Niels Bohr. The second one is angular momentum quantum number, and the symbol is L. It is L. It is introduced by Sommerfeld. Using this quantum number, the number of subcells present in a particular orbit can be calculated. How many subcells are there in a given orbit? That will be calculated. If the L value is 0, based on the values of L, you will get 4 subcells. If the L value is 0, then it represents, L value is 0, it represents S orbital. If L value is 1, it is P. Okay, and so on. There are 4 orbitals, D and F. There are 4. Okay, so the next one is magnetic quantum number. The symbol is M. It is introduced by Landau, and it determines the orientation of the electron. So in which direction the electron is revolving around. Okay, so in which direction the orbitals are located, so that will be determined by magnetic quantum number. And the final one is spin quantum number, that helps to explain the magnetic properties of the substances. The substances can show paramagnetism or diamagnetism. If there are unpaired electrons within the orbitals, they will possess paramagnetism. If there is no unpaired electron, that will show you diamagnetism. Okay, so the magnetic property will be given by spin quantum number. It is denoted by S, and Uhlenbeck and Goodsmith introduced this spin quantum number. Okay. So based on this electronic configuration, there are several principles were introduced. So among them, the first one is Pauli's exclusion principle, which says that no 2 electrons in an atom can have the same set of 4 quantum numbers. So in the previously we have seen that there are 4 quantum numbers. If you take any 2 electrons in an atom, so these 2 atoms never possess the same set of all quantum numbers. So okay, so 3 quantum numbers will be same, but there should be a variation in the 4th quantum number. So that is expressed by this principle was stated by Pauli. So it is known as Pauli's exclusion principle. The next one is Aufbau principle. Aufbau means it is a German word. In German, Aufbau means building. So the கட்டமைப்பு அப்படினு சொல்லுவாங்க. So அந்த எலக்ட்ரான்களுடைய கட்டமைப்பு பத்தி சொல்றது. So எலக்ட்ரான்கள் ஆர்பிட்டால்கள்ல சென்று சேரும் பொழுது எந்த வரிசையில சேரும், how the electrons will be filled up in orbitals, that will be fulfilled by using Aufbau principle. Okay, the orbital with a lower energy filled first before the filling begins in the orbitals of higher energy. In simple words, the electrons will occupy the orbitals in the increasing order of their energy. சரிங்களா, எலக்ட்ரான்கள் ஆர்பிட்டால்களின் ஆற்றலின் ஏறு வரிசையில் நிரம்பும். So how will you come to know which orbital will have lower energy, which will have higher energy? So that is given by n plus L formula. So you know that n value represents the orbit, L value represents the subshell. N is shell, L is subshell. These 2 values, if the values are less, for which orbital the value is less, then that will have lower energy. Okay, and then the Hund's rule of maximum multiplicity. So this rule states that electron pairing in p, d and f orbitals cannot take place until each orbital of a given subshell contains only 1 electron each, or all the orbitals are singly occupied. That means the pairing will be taking place once all the orbitals are completely filled up. that is given by Hund's rule. So for example, if you take p orbital, there are 3 p orbitals like this. Okay, so in each orbital 2 electrons will be there. In each orbital 2 electrons will be there. So in p orbital totally 6 electrons should be there. Okay, so how the electrons will be filling up? So once all the 3 orbitals are singly occupied, then only the pairing will be taking place. So this is Hund's rule. Okay, so இது பேஸ் பண்ணி உங்களுக்கு questions கேட்பாங்க. ஒரு principle கொடுத்துட்டு what is that principle known as? இதில் Pauli's exclusion principle நிறைய முறை கேட்டிருக்காங்க உங்களுக்கு. Okay, the next. So here are some formulas to calculate the number of electrons present in an orbit or orbital, etc. So for example, the maximum number of electrons that can be accommodated in a given shell. ஒரு கொடுக்கப்பட்டுள்ள ஆர்பிட்டில் கொடுக்கப்பட்டுள்ள ஆற்றல் மட்டத்தில் இருக்கக்கூடிய மொத்த எலக்ட்ரான்களின் எண்ணிக்கையை கணக்கிட உதவும் வாய்ப்பாடு 2n². Okay, so based on the n value, the number of electrons in the first cell. If n value is 1, so that 2 electrons will be there in first cell. If the n value is 2, it represents the second cell. 2 square 4, 4 into 2 8. So 8 electrons will be there in the second cell. So if the n value is 3, it represents third orbit. So n square 3 square 9, 9 into 2 18, and so on. So the second formula 2 into 2l plus 1 will give you the number of electrons present in a subshell, given subshell. So it is based on the L value. If L value is 0, 2 into 0 plus 1 0, so that 2 electrons will be there in s orbital. If L value is 0, it represents the s orbital, totally 2 electrons will be there. If LL is 1, it represents p. So totally 2 into 1 plus 1 3, 3 into 2 6 electrons are there, and so on. The third one, the number of orbitals in a main energy level. Number of orbitals. See here in p there are 3 orbitals. In s, for s only 1 orbital is there. So s, p, d, f are subshells. S, px, py, pz, these are all orbitals. So there are 3 p orbitals, there are 5 d orbitals, there are 7 f orbitals. So totally how many orbitals will be present in an orbit will be given by the formula n square. See for example, if the n value is 1, 1 square is 1, in the first energy level only 1 orbital is there, that is s. If you give the n value as 2, n square is 2 square, that is 4, there should be 4 orbitals in the second energy level. That means in the second energy level 1 s and 3 p orbitals, totally 4 orbitals will be there. Okay, totally 4 orbitals will be present in the second, and so on. The number of orbitals in a subshell means s, p, d, f. These are the subshells. Okay, so the number of orbitals in a given subshell will be given by the formula 2l plus 1. See for example, if the L value is 1, it represents p orbital. So 2 into 1 plus 1, that is 3. So totally 3 p orbitals will be there. The number of spherical nodes for a particular orbital is equal to n minus l minus 1. So we have seen that node is the place in which the density of electron, the probability of finding electron is 0. So how many nodes, spherical nodes will be there for a given orbital? So that will be given by the formula n minus l minus 1. Okay, see for example, if you take 3s orbital you take. So here the n value is 3 and the L value for s orbital is 0. Okay, so n minus l minus 1. So 3 minus 0 minus 1 is 2. So there should be 2 nodes for 3s orbital. So we can calculate the number of spherical nodes for a given orbital. Okay. Okay, so far we have discussed some important basic concepts based on the topic atomic structure. So as I told already, so these are all the topics. This is not the list, but there are most of things to learn. But in this short duration, how much is possible? So I have tried to give the things. So the detailed study material and the expected questions will be available in the website, official website. You go and make use of it. Okay, thank you for watching this video. Give your suggestions so that we can improvise the classroom session. Okay, thank you. Bye.